Good day again, guys. Today we'll be doing another reaction. This reaction is going to be a reaction between potassium permanganate solution and potassium dichromate solution. Both reagents that we will be using are in diluted form, so they are not concentrated. As we proceed through this experiment, we will discover certain things and we will learn as we proceed through the experiment. I'm not going to say much before we do the experiment, but as we proceed, we will learn more as we go along. Now, I'm encouraging you guys as much as possible, if you can subscribe to the channel, it will be greatly appreciated. It takes a lot of effort and resources and time to make these videos, and we are doing something constructive, so each one can reach one. So just subscribe as we try to learn on this journey together. Remember, we are making a positive contribution to the learning of science and our world. Now, so we're going to proceed with our experiment for today. Alright, so we're going to try to add our potassium permanganate solution first, and it is already acidified. You can see the color, it is deep purple, and our potassium dichromate is orange, light orange today, because the reagent, it is very dilute, it is not concentrated. Now as we proceed, so we're going to add our potassium permanganate that is already acidified using dilute sulfuric acid to our clean beaker that is in the middle here. Right, our clean beaker that is in the middle here, we're going to add our we're going to add our potassium permanganate solution. Remember the color, it is deep purple, to our clean beaker. To a clean beaker. And then we are going to now add our potassium dichromate to our acidified potassium permanganate solution that is in our clean beaker, and we are going to observe if there is any reaction taking place as we proceed. So we add gently. Remember, we're doing chemistry again. Everything we do gently, and we add small amount, right, and we observe. Right. So we observe for any color change of the original color that we had before. Can put it there for you to see. This was the potassium permanganate solution that was acidified before. This was it. Now this is what we are getting. So we are seeing a bit of change, not a great deal amount of change, but we're still seeing some amount of change. You can see it for yourself. That is what we had before, and this is what we are getting now. So there's some amount of change in color of, let me move the potassium permanganate, potassium dichromate away, and so we can swirl it a little. And see if we're getting any reaction, any color change that is different from what we had before in the potassium permanganate solution. This is what we had before. Can take a clean note. This is what we had before, deep purple, and this is what we are getting now. So there is a slight change, but it is not a very significant change compared to what we had before. You can always compare them, right? So the purple is still there. Some amount of purple is there nonetheless. It's not that intense, but some amount of purple is still there, right? So we are going to confirm. We are going to do a confirmation test to see if a reaction took place between the potassium permanganate and the potassium dichromate. Now, let us talk a little bit more chemistry now as to what is taking place here. what we encountered here is that we add, let me put the potassium dichromate in our picture. What we are having here is that we have two oxidizing agents that are reacting. We have potassium permanganate, that is an oxidizing agent, and we also have potassium dichromate, that is also an oxidizing agent. So what we are attempting to do is to react two oxidizing agents together, and that is why we are realizing that we're not getting much changes in what we had before in the deep purple color of the potassium permanganate solution compared to what we have in now. What we're getting after adding the potassium permanganate is seen here, right? So we're not seeing much of a change. However, we are going to see if some reaction took place between the potassium permanganate and the potassium dichromate. Or we are going to do that. We are going to do a test that is normally done in organic chemistry to confirm whether or not the Mn7+ ion that is present in the potassium permanganate solution, that is responsible for this deep purple color in solution, if it has disappeared. So we're going to react it with coconut oil, which has some amount of unsaturation in it, which means that, as we should know from organic chemistry, whenever potassium permanganate comes in contact with unsaturation, it is decolorized, right? We know that from organic chemistry. Whenever acidified potassium permanganate comes in contact with double bonds in organic compounds, it is decolorized, right? So it loses that deep purple color. So we're going to react with this, the contents of our reaction with, let me put these away so that we are not confused. We are going to react the contents of our reaction with coconut oil, which has some amount of double bonds present in its structure, right? So let us proceed to doing that and see if this purple color disappears, because we are saying, from observation, we are saying that no reaction took place, or if a reaction took place, it was a small amount of reaction that occurred between the potassium dichromate and the potassium permanganate that was acidified. So we are going to check and see if we are correct, or what is taking place here, if a reaction took place. So we are going to add some of our contents of our reaction to coconut oil, which has some amount of double bonds present in its structure. So you can see this is the coconut oil, and so we add and see what occurs if we get a discoloration. So we add, right? So we add, and we're going to swirl it and see what occurs. We're going to swirl it and see if the purple color that we are seeing, if it disappears. So it has already changed a little bit from purple to what we can call that red, and and we observe, we swirl and observe and see if we're getting any more discoloration in the products, in the contents of our reaction, right? Because we want to find out if a reaction took place between the potassium dichromate and the potassium permanganate. Right, so we're seeing a discoloration of the deep purple color. Right, we're seeing a discoloration. The purple color is no longer, you can compare it to the contents of our reaction. So the purple color has disappeared, and this is telling us that no reaction took place, or even if a reaction took place between the potassium dichromate and the potassium permanganate, it was to a very small extent, because the deep purple color of the potassium permanganate is still evident, which is due to the presence of the Mn7+ ion that is still in solution. So we are saying that based on the disappearance of the contents of our reaction, we are saying that from our experiment that no reaction took place between the potassium permanganate and the potassium dichromate, because both of these reagents are oxidizing agents, which means that they accept electrons, and become, which means that they accept electrons as oxidizing agents. And what we have here are two species that are accepting electrons, but there are no reagent here to give up electrons. Thus, no reaction occurred between these two oxidizing agents. Alright, so we are going to pause it. We are going to finish the experiment today on that point, that no reaction took place between the potassium permanganate and the potassium dichromate. Hopefully you guys learned something again. You can always do your literature review some more and learn as much as you can learn about this reaction. I think it was very important for us to do this reaction today, to learn something else about redox chemistry and reacting different reagents together. Thank you very much. Hopefully we all learned something today.